Hi everyone, good morning. This is G. Mohan, Associate Professor, Department of Mathematics, K.S.Rangasamy College of Technology, Tiruchengood. Today we are going to discuss about Fourier Series. In the last session we have got some idea about Fourier Series and we have gone through the formulas of Fourier Series. So Fourier Series is nothing but if f of x is a periodic function and satisfies distress conditions, then it can be represented by an infinite series called Fourier Series as f of x is equal to a0 by 2 plus summation n equal to 1 to infinity a n cos n x plus summation n equal to 1 to infinity b n sin n x, where a0, a n and b n are called Fourier coefficients. Note, a0 is nothing but 1 by pi integral over 0 to 2 pi f of x into dx, and a n is nothing but 1 by pi integral over 0 to 2 pi f of x into cos n x into dx, and b n is nothing but 1 by pi into integral over 0 to 2 pi f of x into sin n x into dx. The above formulae are called Euler's formula in the interval 0 to 2 pi. Note, we have to consider some important points. The values of sin 0 and cos 0, some values. So sin 0 is equal to 0, cos 0 is equal to 1, sin n pi is equal to 0 and cos n pi is equal to minus 1 power n, sin 2n pi equal to 0 and cos 2n pi is equal to 1. Today we are going to give importance to Fourier series in the interval minus pi to plus pi. So if the interval is minus pi to plus pi, then we have to check whether the given function is even or odd or neither even nor odd. If the function is even, means a function is said to be an even function if f of minus x is equal to f of x. If this condition is satisfied, means we can conclude that the given function is even function. So here we consider some examples for even function. F of x is equal to cos x and x square. Odd function, a function f of x is said to be an odd function if f of minus x is equal to minus f of x. Some examples for odd function are sin x, comma x and x cube. Now we can give importance to neither even nor odd function. A function f of x is said to be neither even nor odd function if f of minus x is not equal to f of x. So some examples for neither even nor odd function are x plus x square, x minus x square and 1 plus x plus x square. And we have to give importance to some points. Even function to even function is nothing but even function. Odd function to odd function is nothing but even function. Then even function and odd function is nothing but odd function. So these are the three important points we have to remember. And if f of x is an even function, then we have to consider, then it will become integral of minus pi to plus pi f of x and dx is nothing but 2 into integral of 0 to pi f of x and dx. So if the function is even, means we can consider the interval in the form of 2 into integral over 0 to 2 pi. Then if f of x is an odd function, then integral of minus pi to plus pi f of x into dx will become 0. So Fourier series for an even function in the interval minus pi to plus pi. If f of x is an even function in the interval minus pi to plus pi, then the Fourier series, then the Fourier coefficients becomes a0 is equal to 1 by pi integral of minus pi to plus pi f of x into dx will be 2 by pi into integral of 0 to 2 pi f of x into dx. So if the function is even, means we have to consider a0 in the form of 2 by pi integral over 0 to pi f of x into dx. Then an will be 1 by pi into integral minus pi to plus pi f of x into cos n x dx will become 2 by pi into integral over 0 to pi f of x into cos n x into dx. And bn is equal to 1 by pi into integral minus pi to plus pi f of x into sin n x into dx will be 0. Therefore, in this case, that is, if the function is even function, then the Fourier series will become f of x equal to a0 by 2 plus summation n equal to 1 to infinity a n into cos n x, because the value of bn is 0. Fourier series for an odd function in the interval minus pi to plus pi. If f of x is an odd function in the interval minus pi to plus pi, then the Fourier coefficients becomes a0 is equal to 1 by pi integral over minus pi to plus pi f of x equal f of x into dx will be equal to 0. Then an is equal to 1 by pi into integral minus pi to plus pi f of x into cos n x into dx also will be 0. bn is equal to 1 by pi into integral minus pi to plus pi f of x into sin n x into dx will become 2 by pi integral over 0 to pi f of x into sin n x into dx. Therefore, in this case, Fourier series is f of x equal to summation n equal to 1 to infinity bn into sin n x. Then now we are going to give importance to neither even nor odd function. So Fourier series for neither even nor odd function in the interval minus pi to plus pi. So if f of x is neither even nor odd function in the interval minus pi to plus pi, then the Fourier coefficients becomes a0 is equal to 1 by pi integral over minus pi to plus pi f of x and x. So there will be no change in this. So as it is, we have to consider the Fourier coefficients. an is equal to 1 by pi integral minus pi to plus pi f of x into cos n x into dx, and bn will be equal to 1 by pi integral minus pi to plus pi f of x into sin n x into dx. Therefore, in this case, Fourier series will be, Fourier series is f of x equal to a naught by 2 plus summation n equal to 1 to infinity a n cos n x plus summation n equal to 1 to infinity bn into sin n x. Problems. Today we are going to consider some examples for Fourier series in the interval minus pi to plus pi. So, problem number 1, if f of x equal to x into sin x in the interval minus pi to plus pi, then we have to find the Fourier coefficient bn. So, solution. Here, function given is f of x equal to x into sin x. We have to check whether the function given is even or odd, because the interval we have considered is minus pi to plus pi. So, f of x equal to x into sin x is a given function. So, we have to consider f of minus x, then it will become minus x into sin of minus x, that is equal to x into sin x. The f of x is nothing but f of minus x. So, f of minus x equal to f of x means the function to be considered is an even function. So, in this case, the value of bn will become 0. Therefore, bn is equal to 0. So, if we consider second problem as x into cos x, if f of x equal to x into cos x in the interval minus pi to plus pi, then in this case, we have to find the Fourier coefficients a naught and a n. Solution, given f of x equal to x into cos x, then f of minus x is equal to minus x into cos of minus x, that is equal to minus x into cos x. So, that is equal to minus x into cos x, then it will become minus f of x. So, f of minus x is equal to minus f of x in this case, then the function is an odd function. Therefore, f of x is an odd function. That implies a naught is equal to 0 and a n is equal to 0. The third problem is, if f of x equal to x plus x cube in the interval minus pi to plus pi, then we have to find the Fourier coefficients a naught and a n. Solution, given f of x equal to x plus x cube, so f of minus x is equal to minus x plus minus x the whole cube, then it will become minus of x plus x cube, that is equal to minus f of x. So, in this case, f of minus x is equal to minus f of x. Therefore, f of x is an odd function. So, here a naught is nothing but 0 and a n is also 0. Now, we are going to consider the problem in the form of f of x equal to x square in the interval minus pi to plus pi. So, find the Fourier series for the function f of x equal to x square in the interval minus pi to plus pi, and hence we have to deduce 1 by 1 square, 1 by 2 square plus etc. equal to pi square by 6, and second section 1 by 1 square minus 1 by 2 square plus etc. equal to pi square by 12. Solution, given f of x equal to x square, since the interval we have considered is minus pi to plus pi, we have to check whether the given function is even or odd. So, f of minus x is equal to minus x to the whole square, that is equal to x square, that is equal to f of x. So, here f of minus x and f of x are equal. Therefore, f of x is an even function. Since f of x is an even function, the value of bn will become 0. Therefore, bn equals 0. In this case, Fourier series will be in the form of, Fourier series is f of x equal to a naught by 2 plus summation n equal to 1 to infinity a n into cos nx. So, we know that the formula for a naught, so a naught is equal to 1 by pi integral minus pi to plus pi f of x into dx. But the function we have considered is an even function, we have to consider the interval in the form of 0 to pi. Then it will become 2 by pi integral over 0 to pi f of x into dx. So, that is equal to 2 by pi integral over 0 to pi x square into dx. So, if we integrate x square means we will get 2 by pi into x cube by 3 with the limit 0 to pi. So, we have to substitute the upper and lower limits, then it will become 2 by pi into pi cube by 3 minus 0, that is equal to 2 by pi into pi cube by 3, that is equal to 2 pi square by 3. Therefore, the result for a naught is nothing but 2 pi square by 3. Then if we go for a n, then a n is equal to 1 by pi integral of minus pi to plus pi f of x into cos n x into dx. We know that the given function f of x is an even function and the cos is also an even function. Here f of x into cos n x will be an even function. So, we have to change the interval from minus pi to plus pi to 0 to pi, since the function we have considered is even function. Then n will be 2 by pi integral over 0 to pi f of x into cos n x into dx. So, that is equal to 2 by pi integral over 0 to pi. We have to substitute the function f of x, then it will become x square into cos n x. Now, we have to integrate this function. Here we have two functions x square into cos n x. We have to consider Bernoulli formula. So, we can consider u as x square and dv as cos n x. We have to differentiate u terms and we have to integrate v term. So, u is equal to x square means u dash will be 2x and u double dash is equal to 2, u triple dash will be 0. Since u triple dash 0, there is no need to find v3 term. And here dv is equal to cos nx into dx. Integration of dv is equal to integration of cos nx into dx. Integration of dv is nothing but v. Then cos nx on integration gives sin nx by n. v1 is equal to minus cos nx by n square and v2 is equal to minus nx by n cube. Here there is no need to give importance to v3 since the term u triple dash becomes 0. Therefore, we have to substitute these results in the Bernoulli formula. Bernoulli's formula is integral over u dv equal to uv minus u dash v1 plus u double dash v2 minus u triple dash v3 etc. If we substitute the results in this formula means we will get the result as 2 by pi x u is nothing but x square and v is nothing but sin nx by n. U dash is nothing but 2x and v1 is nothing but minus cos nx by n square. Then u double dash is 2 and v2 is nothing but minus sin nx by n cube with the limit 0 to pi. We have to substitute the upper and lower limits. Before that we have to consider 2 by pi x square into sin nx by n plus 2x into cos nx by n square minus 2 into sin nx by n cube. Now we can substitute the limits. Then it will become 1 by pi square into sin nx by n plus 2 pi into cos nx by n square minus 2 into sin nx by n cube minus 0 minus 0 plus 0. So if we substitute the upper and lower limit means we get this value. So that is equal to 2 by pi into sin n pi is nothing but 0, cos n pi is nothing but minus 1 power n. Then it will become 2 by pi into within bracket we have 2 pi into minus 1 power n by n square. So that is equal to 2 pi into 2 pi into minus 1 power n by n square. Therefore the result for an will be 4 into minus 1 power n by n square. The formula for Fourier series in this case is nothing but f of x equal to a naught by 2 plus summation n equal to 1 to infinity a n cos n x, because in this case bn is equal to 0. So if we substitute the results for a naught and a n means f of x equal to 2 pi square by 3 by 2 plus summation n equal to 1 to infinity 4 into minus 1 power n by n square into cos n x. So f of x equal to pi square by 3 plus 4 into summation n equal to 1 to infinity minus 1 power n into cos n x by n square. But we have to reduce two sections. One by one we can go for reduction part. In section number 1 we have to consider the value of x as pi. In this case the value of x equal to pi is nothing but a discontinuous point. Here x equal to pi is a point of discontinuity in the interval minus pi to plus pi. Because the pi is the upper limit, then it is a discontinuous point. If the value we have considered is discontinuous means we have to consider f of x in the form of f of x equal to f of minus pi plus f of pi by 2, that is lower limit plus upper limit by 2. We have to substitute the lower limit and upper limit in the function, then it will become f of x equal to pi square plus pi square by 2, that is equal to 2 pi square by 2. Therefore the value of f of x is equal to pi square. Now we can substitute this pi square in the Fourier series that we have got. So Fourier series becomes pi square is equal to pi square by 3 plus 4 into summation n equal to 1 to infinity minus 1 power n by minus 1 power n into cos n x by n square. So we have to simplify this. So pi square, if we take pi square by 3 into left hand side means it will become minus pi square by 3, that is equal to 4 into, now we can consider the values for n, then it will become minus cos pi by 1 square plus cos 2 pi by 2 square minus cos 3 pi by 3 square plus etc. Cos pi is nothing but minus 1, then it will become plus 1. Cos 2 pi is nothing but 1, cos 3 pi is nothing but minus 1, then it will become plus 1. Therefore if we take the LCM in the left hand side means it will be 3 pi square minus pi square by 3, that is equal to 4 into 1 by 1 square plus 1 by 2 square plus 1 by 3 square etc. If we simplify the left hand side terms means we will get the result as 2 pi square by 3 into 4, that is equal to 1 by 1 square plus 1 by 2 square plus 1 by 3 square etc. Therefore the final result of section number 1, that is reduction part, is 1 by 1 square plus 1 by 2 square plus 1 by 3 square is equal to plus etc. is equal to pi square by 6. So we have got the result for section number 1. Now we can go for deduction part 2. In this case we have to consider the value of x as 0. The value of x lies in between the interval minus pi to plus pi. Therefore x equals 0 is a continuous point. If the point is continuous means we have to consider the condition as f of x equal to f of that particular value we have considered. So take x equal to 0. That is, if we consider the value of x equals 0 means f of x is equal to f of 0, then it will become f of x equal to 0. So now we have to substitute the value of that f of x equals 0 in the Fourier series we have got. Therefore, Fourier series becomes 0 is equal to pi square by 3 plus 4 into summation n equal to 1 to infinity minus 1 power n into cos x is nothing but 0, cos 0 by pi n square. Cos 0 is nothing but 1. If we expand the series means we will get minus pi square by 3 equal to 4 into minus cos 0 by 1 square plus cos 0 by 2 square minus cos 0 by 3 square plus etc. Cos 0 is nothing but 1, then the series will become minus pi square by 3 is equal to 4 into minus 1 by 1 square plus 1 by 2 square minus 1 by 3 square plus etc. Therefore, if we simplify this, we will get the result as 1 by 1 square minus 1 by 2 square plus 1 by 3 square plus etc. is equal to pi square by 12. So, with this I conclude this session. Thank you.